Hello, everybody, and welcome to TGI Kubernetes. My name is Joe Beta, and I am super happy to be back doing TGIK. For those who might be joining us on the archive who have never tuned in before, TGI Kubernetes is a weekly-ish live stream that we do here. It started when we were Heptio, and now we're continuing it, and we have a rotating cast of characters hosting it. I started it, but Duffy's been doing a lot more lately. And what we try and do is go over sort of what's happening in the Kubernetes world, what's interesting, what's new. And then we do a deep dive on a particular project or subject, try and keep it rooted in open source. And I try and explore things, either something that I'm a super expert on and I want to sort of approach it as a sort of a lesson. Duffy does a lot of that with this grokking series that you can find. Or I try and approach something new where I know nothing about it and we all learn about it together. And so that's a little bit about what we're going to be doing today. So the plan today is to go over a bunch of stuff that's happening in the Kubernetes community. And then we're gonna take a deeper dive into KUDO, which is a framework for a toolkit for writing operators, mostly sponsored by the D2IQ, the old Mesosphere folks that have renamed themselves to D2IQ. So that's some really exciting stuff to see. But I also love to be able to say hello to everybody in the comments. So let me go through and actually scroll back here. So we have Jared and Gerred. If I'm pronouncing your name wrong, try and correct me in the comments. Who's the KUDO creator here. And so really excited to have him online. So that way, if I screw up or if I get something wrong, he can correct me. Really appreciate you taking the time to join us. Yeah, and then we have, let's see, Rodolfo and Don are saying hi to him. Liam, good to see you. A lot of changes coming soon. Okay, cool. So yeah, so like as we go and I'll be like, hey, what about X? I'm going to be interested to see if that's something that you all are already thinking about and working on. So I'm liking what I see right now. I see a couple of things that are giving me pause. And so hopefully we can have a little bit of a good discussion. Lamatti, good to see you. Let's see. Okay, so we can follow KUDO Builder, I'm sorry, on Twitter. And then it's on the Kubernetes stack. And it sounds like they're really working to make this be a collaborative open governance thing as part of the CNCF. And so that's really good to see also. Should and will work with operator SDK operators as an L. Okay, we'll get into that. Okay, we're jumping ahead here. So Martin from the Netherlands. Walid, good to see you. Maz, good to see you. Well, Hanke, I'm sorry, I'm butchering your name. Awesome. Bogdan from Bucharest. Let's see, Tiffany's joining us. How's it going, Tiffany? And Peter and Philippe from Paris. Awesome. Yogi from Singapore. Very great. Well, thank you everybody for joining us. And let's just jump right in. What do you say here? So let me go through and I'm going to switch to my screen. And what we have here is we have a sort of crowdsourcing notes here. So this is using a site called HackMD. If you go to, and Duffy can, or me or Duffy can drop a link here. It's, I think, HTTPS TGIK.io notes. If you go there, that'll take you to this doc. And if you log in, you can put in timestamps or other notes as we're talking to be able to sort of, share links and stuff, because a lot of that stuff gets lost in the comments as they actually thread through. Jordy, good to see you. So let's go through some of the interesting stuff that's happening in the Kubernetes community. We got a lot of stuff. Duffy pulled this together, so thank you very much, Duffy, helping out here. So the first thing is interesting is that there are 3 new CVEs that dropped, and you can see that these things all have sequential numbers, which gives you a clue that they kind of all hit at the same time. None of these things is sort of stop the world critical, but they're all important. So I think, if we look at these, let's see, this first one is rated medium. Let's see, I think this one, Oh, I don't know, like we can just do a Google search for this. I haven't had a chance to actually dig into these things in depth. I know Duffy has. Oh, they don't actually have the details on this one yet. Okay. Well, we'll have to dig into that one, but that one I'm not as familiar with. And then there's a privilege escalation type of thing. So if somebody owns a node, that means they can own the cluster. Definitely serious, but not sort of like stop the world serious. And so, definitely stuff that we want to fix, that we want to take advantage of. And I think there's two interesting things when we look at this. So number one is that these all went through the Kubernetes security process, I believe. So this is kates.io/security. And so this is sort of responsible disclosure of these things. So it's really great to see this process working. And so that as people find this stuff, they report it in a way such that we can get everybody on the same page and get it fixed as much as possible and reduce the amount of harm and the amount of risk that folks in the community go through. We also have a bug bounty program for Kubernetes now. Also, I don't know if these things took advantage of the bug bounty program. That's something that we're not super clear on. The next thing to actually take in mind here is that, this is, I think, for me, a sign of a maturing product. These are the types of issues that, unless people are looking for them and cataloging them, they just going to go like, and then fix it. But the fact that like these things are being taken seriously, people are reporting these. This is, the whole sort of like lots of eyes make, all bugs shallow, or what's that saying, right? Like we're starting to see some of those impacts as people really take Kubernetes and Kubernetes security seriously. So for me, I think seeing these types of issues be identified and fixed and identified and disclosed in a responsible way is really, really exciting. It's really about the maturity of the project. And so as part of that, we have a set of new dot releases. My guess here is that these things are to address a lot of the CVEs. This is part of sort of making this stuff be as coordinated as possible. So there you go. That's a quick summary of what's happening in core Kubernetes. Now, there's a lot of other stuff that's actually happening. I'm going to go through these things really quickly because we got a lot going on. We have a Contour, which is one of the projects we started as Heptio, has joined the CNCF at the incubating level. This is really excited. We've done TGIK episodes on Contour. It is an ingress controller backed by Envoy. So two great tastes that taste great together. The thing that I think is really, really interesting here, though, is that Contour is, that team is working to be well aligned with the evolution of ingress and services that's happening upstream. And so hopefully it follows fast and it becomes sort of one of the first and sort of reference implementations for the new APIs and the new ways of thinking about services that's happening upstream. That's a pretty invasive, interesting set of changes. Tim Hawken is driving a bunch of that stuff with a cast of thousands, but it's really good to see that moving forward and having something like Contour playing a part of it. Let's see, Octant, which is our dashboard that runs sort of in your local context, is a new version released. I hit some snags when I was playing with this earlier and working through the teams. I think I got a new computer, and I think there was a weird misconfiguration with somebody creating some directory in a weird way. But anyway, so new version of Octant, lots of really good stuff coming. It's moving from just a dashboard to something that can help you create resources, port forwarding to services, a way to deal with sort of when you don't have a kube config. And then one of the coolest things about Octant is the ability to have a bunch of plugins. And so they're experimenting with JavaScript-based plugins instead of having to write Go. So lots of really good stuff going on there. So Lamatti's asking, do I have thoughts on Ingress v2, the new services stuff? I don't know enough, honestly. I haven't dug in enough to really wrap my head around it. I do think that when I think about sort of the core Kubernetes APIs, the ones that I'm least happy with is services, because I think we tried to make the service object do too much. And I think if you read the service discovery chapter of the Kubernetes up and running book that I wrote, I try to lay out that like, hey, services it's a standing query for service discovery. It also helps to allocate essentially cluster service IPs that are handled by the kube proxy. And then it also does things like node port, and then it layers on top of that being able to go through and allocate resources in your cloud for doing external load balancing. So I look at sort of the type field of the service object that we have, and I think that that's a bug. The fact that we're trying to overload so much behavior into service, I think really shows that it's not working well, combined with the fact that that ingress is still intimately tied with the rest of this stuff, but it is a separate object. And I think we've learned a lot of lessons with respect to ingress. I mean, ingress started before we had CRDs. And so it's a built-in schema, but it hasn't really evolved. And, the sort of extensions via annotations is not something that I think anybody is super happy with. And so I'm glad that we're really sort of looking to rethink this area of the API from a fundamental level. So bringing in a lot of the best ideas from a bunch of different places. Let's see. So Jared says, we also started a convo of how to move forward on this in the SIG architecture deep dive during the Contrib Summit in 2018. And a lot of the motivation of V2 is in what we went through back then. Yeah. Okay. So cool. If you want to, Jared, if you can find that video and drop it in the notes, that'd be super appreciated, because I think, folks can then dig into that a little bit deeper. Okay, cool. So let's keep going through here. CNCF Ambassador Spotlight Series with Alex. So this is really cool. Alex is a very passionate contributor to the cloud native space. He started OpenFAS and has done a whole bunch of other really interesting stuff. So that's super cool. There's a new certification coming, the security specialist certification. So that's really interesting. I hadn't heard about this. So now there's 3. There's the administrator, the developer, and the security specialists. 3 in the series, collect them all. So this looks really, really interesting. So super cool there. This is crazy. I didn't know that this is happening. So Andrew Spiker, who's a long-term engineer at Netflix, is talking about how Netflix has moved their environment over to from Mesos to Kubernetes. And so really interesting to see them be able to complete that transition. Sorry to all the Mesosphere folks that are dialed in here, but I think, it's really interesting to see them do this. The thing that I think is fascinating here is, and my understanding here is that, let's see, you shared a link with me. I believe they were able to do this in a way where most, if not all, of their application developers were essentially had no idea what was happening. And I think this really sort of, talks to, the whole sort of Kubernetes was built to be built upon, is that this type of thing where you can actually create your own sort of flavor and curated experience on top of Kubernetes. I think that's really a great example that Kubernetes is flexible enough to enable a transition like that. So that's a really, really interesting thing to see them complete that transition. I have somewhere here a Titus sticker, or actually I think it's in my office. Let's see, Duffy's sharing another link here. Let's see if I can pull this one up. There we go. So this is from Chris. Yeah, so they did that without in about a year, and most of the application teams didn't even know that the change was happening. So super cool to see that happening. All right, let's keep going. FluentBit version. So I want to do a TGIK on FluentBit at some point. I think this is really interesting because there's, FluentD started as this sort of super flexible, log collector and transmitter and mutator. And it generally ran sort of like on a per machine basis. And one of the interesting things is that with the advent of things like sidecars, all of a sudden you're like, hey, is that something that should be done sort of ambiently by the platform? Or maybe is this something that should be done in a sidecar from within the pod? And I think there's definitely pluses and minuses from both of these things. But as you start to do that, something like FluentD starts to feel a little bit heavyweight when you're doing it on a per pod basis. And so FluentBit was really, it was started a while ago, and I haven't had a chance to really dig into it, to be a much sort of, streamlined, lighter weight version to essentially, upload and collect logs. And so seeing that work, I think that'd be a really fun project, a really fun TGIK at some point. Let's see, Bogdan is saying, using FluentBit in production, thinking about doing a write-up about it. Yeah, that'd be great. I'd love to see that. And I think it would make a really interesting TGIK episode also, because logging is definitely something that is a top of mind for a lot of folks, for sure. All right, so KubeCon EU, virtual, and apparently you can now get a complimentary pass. So there's a program around that. So that's really exciting also. So go ahead and sign up and join in. I think we're all making this stuff up as we go along, for sure, but it's really good to see the CNCF making this so widely available to everybody. And look at the diamond sponsors. There's Rancher and SUSE. So, they're hitting it up twice. All right, let's keep going. Webinar about Antria and CNI. So Antria is the CNI implementation that we've started here at VMware that uses as a data plane Open vSwitch, OVS. And OVS is really interesting from the point of view of it's a data plane that we know very well, and it's well optimized, and there's a lot of opportunities to actually integrate that with underlying hardware. And so that connection between CNI and allowing for hardware acceleration through OVS, I think that's a really interesting path. And so seeing that through the lens of folks like, NVIDIA brought Mellanox, they're running SmartNICs now, seeing that to, as playing a part and being able to extend CNI through that is a really exciting place where that's going. And the Antria folks in general are adding a lot of really cool features around debuggability, visibility. I think early on when they were starting that project, Duffy and I met with them when we're like, hey, it's a crowded space out there with CNI. But one of the things, there is one who did the pod logging with FluentBit. Thank you, Jukka, for the pointer there. But really great but our feedback was like making this stuff debuggable, making it so that you can understand what the hell's happening would be critical for a CNI. And I think that team has really taken that to heart, and they're working on doing a lot of the work to make the CNI be more visible, more debuggable, because it's just so opaque in so many setups. Okay, more. I'm going to keep moving. Sorry, I'm moving slow here. Tim Hawken did a bunch of tweets talking about how networking works sort of from the ground up. He puts together these sort of mini slideshows and then uploads them to Speaker Deck. And he has a really great way to sort of take these complex things, distill them down into sort of bite-sized chunks. And networking confuses the heck out of everybody. And so having him sort of say, hey, here's the different patterns and modes for doing this stuff, really great. So check that out. Let's see. I hadn't seen this. Duffy found this. So Jamie Hannaford has this sort of what happens when for Kubernetes, which goes into the excruciating detail of what happens when you try and, say, launch Nginx on a Kubernetes cluster. And so I'm sure if I read through this, I'd learn a few things also. But if you really want the excruciating details of what's happening under the covers, this is looks like a really great resource there. So check that out. Yuvrov, nice to see you from India. Okay, cool. Let's see. So the big news coming out from Google was Istio and this thing that they've started called Google started this thing called the Open Usage Commons, and Istio is one of the three sort of starting projects in that. And this is this weird thing that Google's trying to do where they move the trademarks into a semi-independent body. I think there's questions in terms of how independent it is, considering that there's no other industry partners that are joining them there. While the sort of governance of the project still stays pretty tied to Google. There's a lot of drama here. This is sort of open source foundation drama. I think it's really important to look at it through the lens of the ecosystem and where the how this is actually going to benefit sort of, general users and developers here. And I'm still taking sort of a wait and see approach. I'm not quite sure how it's all going to turn out. I don't think anybody's really happy with this move. I think, a lot of folks wanted to see projects like Istio and Knative make their way into the CNCF or something similar versus Google getting fancy with sort of new things like this. But, we're just going to have to see how things play out. I will tell you that, IBM had a pretty strong statement that they're not a huge fan of this move that Google's taken with Istio. And then finally, the Kubernetes podcast from Google did an episode with Wojtek on scalability, and worked with Wojtek when I was at Google. He's been a long time contributor to the Kubernetes project, working out of the Krakow office, probably working out of his home right now, like the rest of us, I'm guessing. And so has really been driving scalability over and over again. Early on, our early versions of Kubernetes, we wanted to focus on making sure we got the APIs and the control flow right, and really didn't take really didn't, drive scalability, because we knew that, hey, we could always fix that later. That was like sort of under the covers type of stuff that we could do. But like, back in the sort of like, hey, Mesos or Docker Swarm or Kubernetes or this or that or the other one, we really got a ton of crap over sort of that initial sort of 100 node scalability limit. Even though I think even now, the bulk of clusters are under that 100 nodes. And so the first SIG that we started in Kubernetes was SIG scalability, to start targeting these things. And they've been chipping away at testing things, finding bottlenecks, fixing them. There's a great definition of what do we mean by scalability, because it's not just number of nodes, it's number of pods, and what is the churn rate and the number of addresses and the size of those things. And so, and Wojtek's been, critical to all of that stuff. So if we look at SIG, scalability, Kubernetes, if we look for that, what you can see here is configs and limits. There's this doc here of thresholds where they have this idea of the scalability limits. And here's like, okay, how many pods per namespace per cluster, and, starting to fill these things out and then start to qualify and quantify these things over time. So, Wojtek is the driving force behind a lot of this stuff. All right, so cool. So that's really cool to see that happening. All right, so that's that. 23 minutes in. I'm sorry, I try and go fast, but I'm bad at it. Let's go ahead and start talking about KUDO. So let's start with, I'm going to start playing around with it, and I have a development environment. I have a kind cluster, get clusters with a single node. So, can I do... No, there's no, okay. Let me go ahead and start an Octant instance here running so that we can actually see this stuff and see what's happening. This is a little small, so let me make this be a little bit bigger. And so as we go through and start doing a bunch of stuff with KUDO, we can go through and actually see what are the resources that it's actually putting here. And one of the things I'm going to say here is I don't think it exists, but it might be fun to think about what would a Octant extension for KUDO look like, so that you can start getting KUDO specific visibility on this stuff. I think the extensibility model of Octant, mixing and matching that with all these different projects, is something that's a lot of fun to think about. Octant already knows how to actually look at custom resources, but there's a ability to actually have plugins around sort of like more domain specific visualizations of different CRDs. So I got that set up, and my plan today, and I've read some of the documentation for KUDO, and we'll let me close some stuff here. Trying to sort of put it in, and I think one of the interesting, I always love when projects do this, is there's a comparison here of like, okay, so how does KUDO compare to some of the other tools that you may be familiar with? And for me, this is always a really sort of a great sign that the community is looking to make sure that they're informing their users of like where they fit in the ecosystem, the trade-offs that are being made. And a lot of times when folks do this, it's not like, hey, we're awesome and these other things suck. It's more like, hey, this is a confusing space. Here's the decisions that we made, why we made them, and why we might be a better choice versus these other things. So I love to actually see that. So some of the things is that like we have sort of infrastructure as code, static format. So like, hey, you can always do things like raw YAML or customize. How does KUDO compare to that? Meta controller, I'm a big fan of meta controller as an idea. I think it's, as a project, it's stalled. And so looking at meta controller versus KUDO, I think there's a lot in common there in some ways, but a different approach. And then versus like writing your own custom controllers, which is, you can do a lot. It's also really, really hard. And so what KUDO is it's a streamlined way. So like a lot of times when we think about operators and when I describe operators, at least my definition of operators is, and this is from the official documentation, I guess, says that operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. And I think that's a good definition, actually. What I would say here is that a controller is something that runs a control loop, and an operator is a specialized version of a controller that has domain knowledge around a specific type of workload. And so the idea is that you write an operator to manage something like MySQL with the end goal of having an RDS-like experience built on top of Kubernetes, where you can say, hey, create me a database. Here's the replication settings. Make the magic happen. I don't want to actually sweat the details. That's the experience that we want to be able to offer on top of Kubernetes. And that's, I think, the dream and in the promise of operators. And the way that we look at, say the difference between something like a Helm chart or an AMI that you're going to pull out of some sort of catalog somewhere versus something like RDS or a fully featured operator is that, it's not just the day one experience, it's that day two experience of what happens over time. How do you deal with failure modes? How do you deal with upgrades? How do you deal with backup and recovery and all that types of things? And really what that means is that we're taking all of that knowledge that's hidden away in, expert operators' heads, that's in run books, and we're distilling that into something that's machine runnable and sits behind an API. And more than any other thing that I've seen, KUDO really embraces that idea of like, hey, let's take those run books and let's turn those into code. And so as we look at KUDO, there's a real focus on making this stuff usable from the point of view of the way that operators think about operating stateful complex systems. So that I think is what's really, really interesting here versus something like, hey, let's use, KubeBuilder, the operator framework, which is like, you got to be a developer, not just a developer, but a developer that is deep in the Kubernetes world to really make that stuff effective. And so I think the barrier to entry for something like KUDO is much, much lower than something like the operator framework or KubeBuilder. Okay, so let's see. Jared says a lot of KUDO's beliefs center in Kubernetes as a programming model with those CRDs and additional controllers. Cool. And then shout out to Elena, one of the maintainers of KUDO and former CI Signal team lead for Kubernetes. All right. Thank you, Elena. I don't know if you're joining us, but thank you for all your hard work here. So it's really about that day two, and that's where operators are different from something like a Helm chart, and making it such that folks who are not programmers, or at least don't self-identify as programmers, or are not super deep in the Kubernetes world to be able to do this stuff is really, really interesting. So I think that intersection is really interesting. Oh, Jared said that Elena is with him now as a CNCF project. She is directly involved with everything. But she's in, was that Czechoslovakia? All right, so she'll hear the shout out later. So yeah, this is the I was just talking to somebody today, like TGIK. I'm like, hey, when we started it, it's Friday. you know, it's the afternoon. Let me grab a beer and start just spouting off on YouTube. And it kind of turned into this 124 episodes later. But it's a shitty time for the rest of the world, right? Because everybody else is probably, you know, at the bar or asleep or something like that. All right, so cool. So that's the general idea. And then the idea here is that with KUDO, there's a way to download and install these things, package them up, without writing a lot of code. And the idea is that it feels very declarative in terms of what you're doing. So you write YAML to actually be able to define a KUDO operator. And so that's really interesting. And so the core thing that KUDO does is that it deals with these things called plans. And you can think about these things as sort of, I think, and I'm still like, we're going to dig into these things, but I think you can think about these things as sort of a, you know, like a run book written in a structured way, kind of like, you know, a workflow type of thing. And so it's plans, phases, and steps. And so you might have deploy, which has a set of phases and steps. And then there's ideas that some of these things can run in parallel and some of these things have to run sequentially. And then with a lot of these things, I think it comes down to how do you deal with failure modes and such. And then these things can be parameterized. And when you look at this, this looks a lot like something like a Helm chart where you have parameters coming into the Helm chart. But the critical thing here is that you actually have a trigger. So the idea is that when a user changes a parameter, because that's a day 2 operation, what happens next, right? And so here it's like, oh, when you change this parameter, run this run book and it'll actually do the reconciliation to actually deal with the parameter. And so let's see. So Lamatti's saying TGIK still going strong. Yeah, we don't have the gong anymore though. Jared says a lot of the meat on the plan is, let's see, I'm reading the wrong thing. Is what will change. We're looking at a more Terraform-like graph approach to the equal sequencing. Events become much more declarative. So a Helm chart could just be something that's part of that. So work with Helm charts and operators versus actually being a pure alternative. That's a great attitude. I think it's really a matter of not like, here's a world, but here's how we can actually build something that can work with a lot of the other things that are happening in the larger ecosystem. All right, so and then there's default plans. So deploy is the only one that's required, but generally there's like upgrade and cleanup. And then under the hood, there's the core things is that you have operators, which is essentially, you know, the sort of like, hey, I want to launch a Zookeeper. You have an operator version, which is a concrete, you know, version of that. And then you have an instance, which essentially binds the operator version plus the parameters, brings that all together and runs that deploy script. So that is how I believe things work. A couple of limitations here. The only thing that KUDO knows how to reconcile is instance, operator version, and operator. So we're going to see this. So like a lot of times when you create an operator, what you'll do is you'll create a new custom resource definition for like a MySQL or something like that. What I think here though is that there's KUDO doesn't create new CRDs. Essentially everything uses these 3 different CRD types. Let's see. So I'm reading the comments here. Y'all are having a good discussion without me. Dynamically create and manage CRDs is on the roadmap for us, but we couldn't do that until CRD v1 hit. And there's a long tail of implementation to actually get there. Yeah, that sounds about right. And so it all uses these sort of super generic CRDs. And then a lot of things change in CRDs to actually start getting there. Yeah, so the downside of this, and a lot of constraints, the downside of this versus having sort of a CRD per operator is that it doesn't work as well with something like RBAC. Because with RBAC rules, you can say, hey, I want to like let somebody create a MySQL, but not let them create Zookeepers. And that's something that you can't do out the gate with something like KUDO, because you only have like everything is using an instance type. So maybe you can prevent people from creating new operators and new operator versions, but if something's in KUDO, then anybody can actually create it in their namespace. So that's something to think about there. Yeah, RBAC is a pain until the dynamic CRDs, then it's a real story. Now you could go through and use something like a validating admission controller to do some policy here. And this could pair well with something like OPA, I'm guessing, to be able to implement that type of policy. But using sort of core RBAC doesn't necessarily get you there. All right, so I think the question here is, do we want to go through, and I think maybe we do, let's go through and like just try and use one of these things, start with, and then we can actually start tearing it apart and look at it as an example. And so I think like versus actually just sort of reading docs together. And so what I'm going to do here is that we can do kubectl kudo install Zookeeper. What I'm going to do is I don't have the kudo command line utility installed, so let's get that going first. Here's CLI usage, set this up. So I'm going to do, I do have crew installed. So we'll go ahead and do that. Let's see if this works. All right, there we go. Okay, and then I guess we need to do kubectl kudo init, right? So this will install sort of the core kudo stuff. Now, one of the things I always like to do here, well, let's see, kubectl kudo init. What? What did I do wrong? That's odd. Yes, that is odd. We installed it. Okay, so so it thinks it's there. Oh, I didn't do this. Okay. This is me being bad. Okay, there we go. There we go. Okay, I'll have to add that to my regular old bash RC. I actually switched to a new computer, and so confusion. I'm still like finding little things like that going on. Okay, so here we go. So here's the kudo plugin, and this is actually really cool. So kudo init. One of the things I want to see here is okay, this is really cool. So we can do dry run output YAML. Say, wait for kudo to install. Set up kudo in your local environment only. What does that do? What does it do? Well, okay, so let's see. So if we do... So I'm wondering, like, what is it going to change on my sort of local environment? Is there any documentation on what happens when I call kudo init, and like, what is it going to actually drive? Client, what is the client config here? Okay, it'll set up kudo repositories and copy stuff in there. Okay, so like, okay. So it's not going to go through and start rewriting dot files and really hork things over. All right, let's go through and we'll do this kudo control dry run output YAML cd 24. And cert manager CRDs. Oh, I have to have cert manager installed. Oh man, okay, I didn't know that. Okay, cert manager. I haven't done that recently. Do I need to have like the Acme stuff set up and all that? Or do I just need to have some cert manager installed? So James left JetStack, and he's going to still be working on cert manager. He hasn't announced where he's going yet. That's brand new. You're hitting a rough edge while we automate this. You just need the base controller installed. Okay, so that's easy enough. How do I go through? Where's the install instructions? Installation, Kubernetes, regular manifests. So here's how I roll. So I go through and I do curl-l as a, oh no, it's L capo. And I do cap Oh, oh, brew install cap. All right, I'm gonna have to deal with that later. Okay, we'll just do a cube control apply -f, and this says that I need the validate false. Why does it need validate false? If you're running, okay, we're running a new version. Okay, so -f cert managers. We're yak shaving right now. Okay, so that installed cert manager. Okay, and now so what are you all using cert manager for? Is this to actually? All right, so let's the lawn people are outside. Hopefully you don't hear a leaf blower going on. Okay, so let's go through. We'll save this to KUDO init.yaml, and then we'll pull that up into KUDO init.yaml. Okay, so let's see what we got here. So we have a CRD for the operator. Okay, that's a bunch here. And y'all don't have schemas in there, so you don't have that yet. We have a CRD for the operator version. Oh, this one does have schemas. Okay. Maybe there's just not much to the operator. Okay, and then a CRD for an instance. And so, okay, so there's a bunch of properties there. So we're not going to do any of that. Okay. And then let's say we have a namespace called KUDO system. We have a KUDO manager service account. We have a role binding for cluster admin. So, okay, so it's important to note that KUDO is essentially being installed as root, which is an interesting thing. That is just something to be aware of. There's a mutating webhook. And what is this used for? Instances. Okay. So I'm guessing that this is used to maybe do some sort of validation and transmutation of the instances resource as you go. Let's see. I'm reading comments. You all are talking and I'm not paying attention. Like, give me a second here. So all the cert manager stuff is brand new, not automated yet. I can do it with like an unsaved self-signed webhook CA, but we'll do it. Okay. Operator mostly established a one-to-end relationship right now, maybe other metadata later. Okay, and their flags install is not root as well. Okay, cool. Exactly on the webhook. And then somebody's asking what's the limitations of using as non-root. I think it probably just works within one namespace. But there's still the awkwardness of like the CRDs need to be installed globally, so you need root to install the CRDs, but maybe it just operates within a singular namespace. All right, and then with Cert Manager, there's a self-signed issuer. And so using Cert Manager to essentially do the CA stuff. And then there's a certificate for the KUDO Controller Manager service. And then there's a service, a stateful set here. Well, we're going to have to see stateful sets and kind are always an interesting combo. We'll have to see if we can make that work. So why does KUDO Manager need a stateful set? That's an interesting question to me. Is it just for the cert? Volumes, name, cert. It's a secret. I don't know why you all need a stateful set there. All right, cool. And then there's ... here. What? Why is there ... at the end? I don't know. Why is there ... at the end? That confuses me. Oh, well. Well, let's just go ahead and we'll just do the init, and we won't waste any time on that. Okay. Install the CRDs, the namespace, the webhook, and the controller. So now if we go here, let's see. Oh, it's left over from how KubeBuilder does its init and HA stuff. Okay. End of the YAML. Does dot 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 mean end of a YAML file? Is that like a YAML thing? Did I not know that? That's kind of cool. All right, so custom resources. There's no, this is actual custom resources, not custom resource definitions. That's custom resources in the namespace. But we can go through and we can look at the KUDO system namespace. And here we have the certificates, request, manager, issuers. So we have an issuer here. Ooh, a lot going on there. Got the okay, we need to change it so that manage fields gets collapsed by default, because that's a lot of gunk. That's a lot of gunk going on here. All right, so this is a webhook conversion. So, okay, so cool. So, okay, so you're essentially using Cert Manager for doing your own certs. I'm assuming that's for managing the certificates for talking to the API server. This is something that Spiffy and Spire would help with if we actually got that well working out through the ecosystem. So add that to the list of things we got to do. All right, cool. So now, all right, so we have KUDO installed at this point. Where are we at? Okay. Oh, I'm now, oh, we're going to try to do Zoop here. Okay. So now I should be able to do install Zookeeper. All right, operator default Zookeeper created. Oh, and it created an instance also. Interesting. Okay. So that's something that's a little bit confusing, is that you're installing Zookeeper, but it also does an instance. Is there, I bet you there's like a way to say install, but don't actually launch an instance. Right? Create namespace, instance, so there's an instance name. Skip instance, yeah. All right, but this is the idea of like, make it all magic. All right, so let's see what we got going on here. So this will be in the default namespace probably. And so now we have, okay. So this is something, so it's interesting that operators actually gets installed into this namespace, the Zookeeper operator. Does that mean that it's not available in a different namespace, or it gets installed? So this is interesting, because now these operators feel like they're, like KUDO itself is installed across the system, but the operators all exist within the existing system. I would have kind of expect that operator and operator versions would show up in KUDO system, while the instance would actually show up in the namespace. So that's something that's a little bit, but I guess like this is like, hey, you give this namespace access to be able to use this thing. So we can look at the YAML here, and again, so status is that it's deployed and it's completed and like magic stuff happened. So as far as KUDO is concerned, this thing is actually good, but I should be able to do kubectl KUDO and then get instances, and we have a Zookeeper instance. Zookeeper. Okay. Is there a way to actually introspect that? Yeah, cool. Okay, I'm wondering if like, can I actually sort of get information about that? Kubectl KUDO plan. Okay, and so this instance is called Zookeeper, right? Okay, cool. Last finish, then validation was never run. So like, yeah, we got, it sounds like we kind of got a Zookeeper up and running. So if we look at, we have 3 pods in Zookeeper instance. And using the default service account. And it's a stateful set. Oh man, they're loud out there. Sorry about that. Do I have my... All my windows are closed. All right. Sorry, this mic is pretty good, so you probably don't even hear it, but it's bugging me. Okay, so we can start looking at this, and like this is now a stateful set here with the Zookeeper instance. They're all running. Very cool. Now, I am not a Zookeeper expert, so I assume though, that if I found the way to connect to Zookeeper from the client, I could just go ahead and start using this. But these things are running, and we have data dir there. So like, wow, so this thing's all up and running. That's super cool. Okay, so now so now we have the stateful set. We can get the pods, and all right, so there's a validation task. It's run as part of the deployment, which ensure that everything's in a healthy state. Now, is the idea here is that like you can run the validation task like all the time, or I think one of the things that I would be interested in, so I can do plan, trigger, so instance, Zookeeper, instance, plan, validate. So I can go ahead and, name. All right, so that got triggered, and so that's sort of running asynchronously. It might be cool, like to actually be able to sort of follow that status. Okay, so cool. So the plan, deploy, validation, serial strategy, not active. So it's not active. Did it run? Okay, status. It's a little bit confusing to me that this stuff is under sort of plan in the command line versus under sort of versus under the instance. Right, and this is some of like, you know, command line theory, right? Command line interface theory. I'm very much a noun verb person, where it's like you talk about the thing and then there's a bunch of things that you could do with it. Okay, so I can do history here. So it still says validation was never run, but I thought I triggered it. So I'm wondering, triggered validation plan. Okay, it doesn't error. Did I do something wrong? Oh, validation is it's not validation. Okay. All right. Failed to update instance, overriding currently scheduled or running plan validate with validation is not supported. Oh, interesting. So like the thing got triggered for a non-existent plan, and now it's like running, but it doesn't exist. And so, ooh, we found our first bug. Okay, how can I go through and fix this? Is there like a, you know, is there sort of a CRD that actually keeps track of what is the running, like where's the state here for this stuff? Is this in RAM in the controller? Oh, it's actually written into the instance. Okay, so if we go through and we look at the instance, so we can do custom resource, instances, Zookeeper instance here. If I go and if I look at the YAML here, oh, I think the newer version of Octane actually lets you do this stuff. Validation never run, deploy, plan status. Okay, it says we're doing validate now, but it's like, I don't know what that thing is. And so it should probably like, thing should error out and actually clear the plan execution at that point. Okay, so now I can do kube control, edit, instance. And then this one is called Zookeeper instance. All right, and now we can go in, and I assume if I just sort of like, let's delete this, and will that work? Nahuel from Argentina, nice to meet you. Did I just delete those things? Let's give that a try. Yeah, that should be okay. Cool. So now we're gonna try and trigger validation. Oh, did it not apply? What did I do wrong here? Validated, still confused. Is it, oh, maybe I have to, I bet you I have to do something like this. Let's see what that does. Oh, failed to update. Wait. Zookeeper now be patched. Admission webhook. Denied the request. Failed to update instance. Canceling a currently scheduled running plan. Validate is not supported. Uh-oh. Delete and remake the instance, I guess. Yeah, so, okay. Both the admission hook and everything. So, okay, so this is a good bug. This is a good bug. I think there's a way that we can go through and like with root bypass the whole thing. But what we're going to do is we're going to do kubectl delete instances Zookeeper instance. We're going to go ahead and delete that. When we do that, what we're going to see is that I didn't use the KUDO command line, but what should happen is that that should actually go through and actually deletes the stateful set also. And either the controller is doing that, or what's happening here is that there's sort of the parent-child garbage collecting relationship between the instance and the resources that the thing is actually creating under the covers. Okay, so now we're going to actually do kubectl sorry, this is KUDO. Let's see, and now we're going to have, what's the command to actually create one? Install, init, get, update, upgrade, version, test, search, repo. Oh, do you just go through and actually maybe like just install again? I mean, clearly we could write the YAML and actually apply that for the instance, but I don't see like, is there a helper to help me actually sort of create an instance? Or do I just want to go through and do install? Yeah, install again. Okay. All right. All right. We'll do that again. We created the instance. It's like, hey, it's already there. Don't worry about it. Now this thing is, the stateful set is actually booting up. This is one of the nice things right now about Octane is that it actually has a live connection. And so the thing updates all the time. You don't have to be refreshing the thing, which is really nice. Okay, so now we're up and running. I will be careful to actually do the trigger validation, not validate. If I do that, oh, it's still deploying. Currently scheduled or running. So, okay. So it's still deploying. I thought I did the same thing again. So we do instances, this thing. And so this is the place where it's like having a nice view here that shows the plans and the history and all that would be nice. Okay. So deploy is run to completion. We're in good shape. And now we can trigger it again. And now if we look at, so KUDO plan status, and then I have to do its instance Zookeeper instance. All right, cool. It's completed. Okay, so I guess one of the things that I think would be interesting here, and I think I'm wondering about sort of the day two stuff. Do you need to manually trigger something like a validation, or can you set up the thing that says like, hey, you know, every hour run this validation, and like, you know, and then the validation, there's sort of some auto remediation, and then there's also like, hey, I found a condition I don't know how to deal with, and like maybe you could hook this up to something that would then start paging people, and so that would actually be that would be really interesting to actually see like how does this work sort of in reality to make sure that things don't drift and that things stay valid and that you're running these sanity checks. Okay, so yeah, so that's a event triggered plans with cloud events is one. Oh, cloud events, yay! Okay, so then you could start dealing with like, hey, there's an event that something happened, and you could have a whole ecosystem of what you want to be able to do. Okay, cool. And then that might be a, oh, so you could react to the cloud event to do the trigger. But then you could have maybe like one of the things to think about is maybe the output of one of these things could be that you're actually surfacing a cloud event also, right? And I'm wondering what that would look like. Because one of the things that I think I would love to get your thoughts on is, you know, you look through this sort of plan deploy and the phases and the steps this has a lot in common with something like the Argo workflow engine, right? And so, and there's definitely a, you know, cloud events triggering and, you know, interaction with Argo also. And so I'm wondering if there's some sort of, you know, synergy there to actually be thought about and created. So that would be pretty cool too. Okay, so that gives you, I think, gives us the general idea of what this looks like. And then you could have an arbitrary set of plans that you could trigger here. So you could have something to do an upgrade. You could have something to do a backup. That's what I'm assuming. Now, one of the things that I think is interesting is, and I think this might be a limitation of the KUDO point of view, is, you know, how do you want to model doing a backup with something like an operator, right? And one way that you could think about it is that maybe you have another CRD, which is a backup of your database. And then you have a restore action that's going on from that. And like modeling out a richer set beyond instances, I think is something that would be missing out of here. Or it's like, you know, let's say you're doing a database and you actually have primaries and replicas and you want to create, and each of those things has a CRD. And then there's a parent CRD that represents the replica set. And then there's ways to actually interact with those things dynamically. So that's the type of sort of more sort of richer interface that you can get to when you're writing an operator from the ground up. And I think that's something that would be difficult to squeeze into KUDO or something like MetaController also. And so, yeah, okay. So with the dynamic CRDs, you're thinking about that sort of like, how can we do that richer API? And actually think about the interaction across a bunch of CRDs versus trying to squeeze everything through the instance. And then restores are harder in that world. Yeah. Yeah, I think, you know, there's backup and restore and disaster recovery. How does that relate with sort of more generic systems like Valero, and how would you actually have Valero interact with operators? I think that's something that I haven't seen anybody explore yet either. That would be really interesting. Yeah, and then actually maybe like the backup scheduling is something like a Valero that knows how to deal with the, like, here's a bundle of data, squirrel that away, replicate that, make that happen someplace else, because that's clearly the type of thing that you don't want to be building into every operator. Okay, cool. All right, so that I think is a good run through of what it's like to use KUDO. Now what I want to do is I want to take a look at what does it look like behind the scenes here. So there's a whole set of the docs here which talks about developing operators, and I think, you know, I do like reading through docs. I'm a depth first learner. I like to read all the docs and understand everything, but I think for TGIK it might be best for us to actually look at how that Zookeeper operator was actually implemented under the covers. And so if we go to the GitHub org here for KUDO, what we can see is under the covers, there's this repo called, well, first of all, there's a repo called operators index. And so when I say install Zookeeper, what it's doing is actually going and fetching and caching this. And here's sort of this, this metadata object. This is not a CRD, but it uses the same format, which I think is really, or maybe this is, no, this is not. This is a, this is an index API version. So this is actually, this is one of the things I think is fascinating, is that the whole API version kind and name stuff, that sort of triad is finding its way out as a useful sort of like, you know, marker on any sort of data file, you know, YAML or whatever, to say, here's what this thing is, even if you're not checking that thing, you know, or submitting that thing to a Kubernetes Kubernetes cluster, which is really interesting. So I'm guessing if I look at .kudo, this repository is repositories.yaml, which actually points to this thing here. So this guy hooks up to here. Well, the URL here is in a cloud storage thing, because probably to prevent people from hitting GitHub API issues. But I'm assuming then that if I go through and look at this, if I do let's go through, that this is a snapshot of the stuff that's in that GitHub repo. No such key. Oh, sorry. So there's an implied, oh, community. There's an implied thing under that. That actually probably points to this, I'm guessing. Okay, index.yaml is implied there. Okay. Oh, and that pulls it down, but curl dash lo. Oh. Let's do a little bit of spelunking here and how this works. Index.yaml. Yeah, and so this ends up pulling together, it looks like maybe it integrates all the various files that we have here so that we get, like here's Zookeeper that actually points to, oh, interesting, okay. This points to, so there's probably a build process that gets built out of this. So in any case, this stuff gets all uploaded to Google Storage, you know, or S3 or wherever. So it's just dumb old things, dumb old, you know, HTTP hosting to be able to host one of these things, which is always nice to see. And then I'm assuming that like this is just a tar file that has a whole bunch of files in it. Those files then are actually coming here from the operators repo here. And so I have that, I cloned that. And so we can look at operators and we can look at repository Zookeeper. And there's a bunch of stuff going on here. So this is super cool. So here's the KUDO's version that maps to different Apache Zookeeper versions. Okay, operators index triggers a CI/CD to upload artifacts to GCS. Okay, cool. Cool. Okay, and then it says where this is going to match the OCI artifacts so that we can push to any artifact. Oh, cool. I love, so this is a whole nother thing that we got to explore at some point, is the idea that OCI registries are turning into a generic artifact store, which I think is super, super cool, because like S3 is great, but S3 plus a little bit of lifecycle and versioning metadata around it for artifact management is even better. So that's something that's really, really interesting. And then that actually provides a much more structured way for being able to deal with air-gapped environments, being able to deal with replication into, you know, sites that may be operating over a WAN or disconnected or what have you. And so we're really starting to see more and more happen around that. And I believe the next version of Harbor is going to be OCI artifact compliant, so it can actually host these things also. So really like where that world is going. That's really exciting. Okay, so the operator here, fundamentally, this is what we got. There's a bunch of templates that are involved here, which are interesting. And then there's the params file. And so the params file here, again, so this is like, this looks a lot like a Helm chart, right? I mean, but it's again focused for sort of what happens when you change these things and having a general sort of reconciliation runbook type of thing that happens. If the default way that you change these things, when you change these things, it reruns the deploy trigger. I saw that in the documentation. But there's some things like right now, this particular thing doesn't know how to handle changing of the storage class. And so that'll actually trigger something called a not allowed trigger. But I'm guessing that this will tickle that bug that we hit earlier, where it'll get you into a hork state where it's like, hey, I don't know what not allowed is, but I can't run it, so I'm not sure what to do, and I'm in a stuck state. So this is probably something that's worth testing out. But things like disk size and storage class, those things are too big a change for this particular operator to deal with, so it'll actually keep you from doing that. But there's a bunch of other stuff that you can do that'll actually cause essentially a redeploy of Zookeeper, and you're up and running here. One of the interesting things, and I'm wondering how that would fit in here, is that, you know, and thinking of some of the experiences from like Bosch in the Cloud Foundry world, is that, you know, if I go through and I change the CPU limit, how disruptive is that going to be? Is that going to actually sort of take all of these things down, or is that the type of thing that can do a rolling update and it's not going to be disruptive? Is there a way to essentially do a little bit of a dry run of these things? So maybe like, hey, is there a way that you can have, you know, parameters to a particular trigger so that you can do a dry run and then have that thing have output? That's something that I think would be interesting to look at. Oh, Duffy's taking off. Thank you, Duffy, for all your help. Really appreciate it. Have a great weekend, man. So that's something that I'd love to explore. And it sounds like not yet, but that might be an area to take a look at. And again, that's the type of thing where it's like you start looking at this through the lens of like, you know, something like an Argo event type of thing. Now, the interesting thing here is that let's look at the operator here. So we have a bunch of tasks and plans. So the deploy plan happens in serial. The first phase is called Zookeeper and then validation. The validation plan happens in serial. And there's let's see, the steps are connection and cleanup. So validation. Okay. So this is essentially a DAG here where the tasks can be reused across multiple plans. And that's really interesting, I think. And then the individual tasks here are, hey, just apply these resources. And so, okay, so we're doing a deploy, the infra and the app tasks are what we're doing. And so there's the infra, which does a bootstrap health check services and then PDB, and then apply. Oh wait, okay, I see. So there's infra and app, and then applies the type of task. And I think that's something we can look at the docs, the different types of tasks that can actually come into play here. So the idea is you do a bunch of stuff to set it up, and then you do the stateful set. And so there's an implication here that these things are actually sequenced, right? Or that's the parallel here. Okay, the steps are sequenced. Or no, this is one step. Okay, in any case, now the interesting thing here is that when we go through and we look at Bootstrap, let's look at these. So we have Bootstrap. This is a lot of bash because, you know, but it's a config map. So at the end of the day, we're creating a config map and there's templating built in here. And so what we see here is, again, this looks a lot like Helm. It uses Golang templating behind the scenes to be able to do this stuff. And so the, you know, as we look from the params on down, this is the stuff that matters. And so some of this stuff I assume can change and some of it can't. I'm assuming that you can't change the name of the thing and actually have it actually maintain its identity. But if we look at Bootstrap here, there's name. Is there other places where we see? Yeah, and so here's the params: client port, server port, election port, that type of thing. Cool. And then health check. Similar thing, here's the script that gets run. So the idea is that we do expansions. These things get written into config maps. And then I'm guessing that the stateful set loads the config maps and that image knows to actually run these things and they get mapped into a specific mount path. Yeah. So that looks like that's the stuff that happens here. So that's pretty cool. And then a lot of the port stuff actually comes into play too. Very cool. So this, I mean, so in this case, this looks a heck of a lot like a Helm chart with some more sort of prescriptive ways of what you do when you change parameters and the ability to have these extra triggers with the idea that this thing is actually running in an ambient way. Yeah, but you know, and so like you're like, oh, but Helm had Tiller and it got rid of Tiller in V3 and this thing has a controller. Well, how does this controller compare to Tiller? So that's something that I think is interesting to examine. I think the big problem with Tiller was that the security model around Tiller was not something that was well understood, and Tiller didn't have this rich sort of triggering model that could happen at any time. And so really the value prop around Tiller and the security considerations meant that it was something that, you know, really made sense to move away from with Helm 3 for those folks. Because everything that happens here works through CRDs, custom resources, there aren't nearly as many security considerations as Tiller, because Tiller had a separate gRPC API direct to Tiller, and that created a whole bunch of problems there around auth and confused deputies. So Jared's asking, we're considering would like your thoughts on being a bit more structured, YTT, JSON, Starlark, etc., to get around some of the templating hell. Yeah, templating hell is the way. I would view this through, you know, like one of the things that I would think about is that as we look at apply here, you know, you could have a legacy apply, and then you could have something along the lines of where you have a, custom apply, where you had the ability to actually have custom appliers or processors that could be installed in some ways. And whether this is a custom container image that you run on this thing to be able to do this transformation or what have you, the idea that you sort of separate that out and you have sort of less knowledge. Now, the output of this thing would be like you apply, and then it leaves some breadcrumb with all the YAML. And then so maybe it's like, maybe instead of calling that thing apply, you would actually call it sort of a processor, right? And so that starts to look like meta-controller webhooks, you're right. But I would do it like it's really about which tool set do you want to use. And generally, like people wouldn't be writing custom code there. They would be like, oh, I'm going to use the YTT or the JSON, processor. It might be worthwhile to take a hint from something like Kustomize, because Kustomize does have this extensibility model for being able to essentially do custom processors that take, okay, here's some parameters, run it through this thing, and it generates some YAML. One of the things that I think, we've been thinking about inside of VMware, and Brian Lyles has been playing around with, is, how do we deconstruct GitOps and think about GitOps as being not about Git, but about being having a external system of record and a continuous application of that. And so one way to think about this would be that maybe, we have a way to create an external system of record, and instead of using Git, this is actually using a internal sort of, system of record, and then there's a generic applier that knows how to apply that, whether you're pulling stuff in from Git. So there's definitely a spectrum between the way that we're looking at doing this templating with the automatic application when you run this versus something like GitOps, and that's something that I think is worth exploring a little bit. There's no right answers here, and I think there's a soup of ideas, and over time we're going to be building up the right sort of building blocks. None of these things is rocket science to get started with. I think it gets more complicated as you start thinking about some of the edge cases and how you deal with those. So this is super cool. And then sort of validation here ends up being just a job that runs. Okay, cool. And so one of the things that's missing here is that, okay, you validate, it has a restart policy of never, which means that it can fail. If it fails, I assume that there's like, hey, you're just reading the sort of the result of the job, and then maybe you're reporting that back. Understanding the result of the validation is something that would be interesting. And then like, okay, so then that plan fails, and then now it's like, okay, the plan failed, now what? Now what you need to do is understand a lot about KUDO so that you can actually go down and dig into like, oh, well, this trigger ran this plan ran a job, this job ended in a failure, and here's where the logs are. And so if you don't have that sort of connection between the logs of the job with that, so like I would really be thinking about what's a way for a plan to be returning richer information about what happened. I think we see this a lot of times with things like CI/CD systems. You can run a CI/CD run, and when everything works great, it's great. When things fail, you're like groveling through log files that are hard to find, and you have no idea what the hell happened. And I think that's the thing that I would be afraid of here, is that like, how obvious can we make it that things are to debug, right? And when these things fail, that's something that I would definitely be looking at. Cool. Let's explore a little bit here. Are there some of these things that are maybe a little bit more trickier, that do some sort of custom steps? Like one of the things that I would love to look at. Oh, there's a lot more going on here with the Spark one. Latest configuration. Let's see, resources. Let's see. Kafka is a good one. Spark is a good one. Okay. All right. Oh, and then Jared says that there's a testing framework. Yeah. So let's look at that real quick. Oh, I'm looking at docs. Okay. Here's the operator. Template. There's a bunch of parameters, but the operator itself, there's a bunch of applies. All right, cool. So that's a bunch of tasks. All right, so with Spark, you can do, there's the deploy plan, and that goes through and that does preconditions, installs some sort of webhooky thing, I guess, installs Spark, installs monitoring, history. Okay, cool. And then it looks like there's only one plan there then for that one. And then you said that and then you said the Kafka one is also interesting. Okay, let's take a look at that. Operator. All right, so there's STS, configuration, service we apply, enable cruise, spec parameter. Oh, this is interesting. Okay, so enable cruise control. Oh, kind toggle. Okay, so the toggle means that like this thing actually says whether you install those things or not. And I guess one of the interesting things is like, you know, hey, if you change this, does it actually go through and delete those things? And then this one is interesting because here, this one is of kind pipe that says you're essentially turning these, your cert generator.yaml. What is? It's doing init containers, doing that. Volume mounts is, okay, you have a cert called cert out. I'm assuming, okay, so I have to look at the pipeline stuff. Yeah, generate the cert, make it available to later tasks. Okay. Yeah, I mean, this is the type of thing where it starts looking a lot like something like Argo or even Tecton, right? So understanding like, you know, how many sort of like, you know, directed graphs for running tasks do we need? Are there ways to actually bring these things together? That's something that I would be thinking about. So cool. So let's go back to the docs here and okay, so now we understand more. So there's an apply task that we talk about, delete task, toggle task. So okay, yeah, there's a parameter actually decides whether you do that or not. Pipe task. So this actually runs something and then saves things as either a secret or a config map. So you essentially save it out. Okay, and it sort of knows magic like oh, it has to be an init container and an empty dir and sort of probably completes the sort of pod spec to bring it all together. And so this is a way that you can essentially do random commands to generate data here. So that's pretty cool. And KUDO operator task, specify a dependency on other operators and parameterization. Then a dummy task, what is a fail to succeed on demand for debugging? Okay, that looks useful. So one of the things that I'm wondering here, and I'm wondering how you actually think about this, and maybe probably jobs are the way you would do it, is that like a lot of times is that, you know, you set up a stateful set, something fails, right? And you lose a pod and it gets recreated. And when that pod comes back up, you need somebody from the outside to essentially, in a distributed system, poke a bunch of stuff to be able to sort of reintegrate it into the cluster and have the cluster sort of quiesce. And I'm wondering, like, what would that trigger be like? I'm like maybe, you know, one of the things that would be needed here would be like, oh, if you see a restart of any of these pods, then trigger a cloud event and then have that cloud event trigger a plan and have that plan run a job and have the job go like, hey, let me make sure that everything is hooked up, talking to each other and configured correctly. So maybe the missing piece there is that sort of reactivity loop of generating the event based on generic things that are happening in your cluster. And I'm wondering if that's something that you all are thinking about, that sort of automatic remediation. Because clearly you can get to the point where, oh, like something failed, I need to remediate. Let me go through and do KUDO, trigger and actually trigger things manually. But like the holy grail is we want to make this stuff be automatic and foolproof and debuggable, right, and obvious. So Jared here says, we're working with a user right now who wants to manage this for on-prem Cassandra. Cassandra is a great example. Data node failures, and they'll let the operator intervene in am I standing it back up or rebalance to another shard, that type of thing. Yeah, so that's, I think, the interesting thing. I'm thinking about some of the operator work that we're doing inside of VMware as we continued some of the efforts that we started with Pivotal. Coming from Pivotal around creating operators around things like Gemfire is a great example. Gemfire I'm trying to think what else we're working on there. But yeah, so that's sort of like, hey, something unexpected change. How do we sort of trigger remediation with the idea that you probably want, and this is part of the testing, is you probably want most of your plans to be idempotent, where if you run them over again, it's like no harm, no foul. They're going to try and actually just make something happen. And I'm wondering if you actually model this as, hey, plans need to be idempotent, or whether there's going to be some plans that are mutating and some plans that really are idempotent, and whether that's some metadata that you're going to want about the plans. So lots of interesting stuff to explore there. Okay, cool. All right, let's look at the testing stuff real quick, and then I think I should probably call it because we're about an hour and a half in. Okay, so you can install KUDO. So the first test, what does the test look like? Inside the example test, we create our first test install. So this creates an example deployment. And now we have a test assert. Oh, interesting. So this is a fascinating way to view it. Now, is this built into KUDO, or is this a separate type of thing that you all are doing? So what's happening here is that if you have a YAML called assert, what you're essentially saying is that it's sort of a partial overlay. And I think what you're saying is that this should be able to overlay on top of the real resource without any changes. And so it's like, I want to assert that everything listed here matches up there. That's a really interesting way to think about testing. So yeah, assertions based. So I like that idea of like, hey, if I applied this diff, would it change anything? And if the answer is yes, then you're then you validate, then you essentially fail the assert. Now this stuff gets a little bit complicated because like you may have, anytime where you have this type of overlay, you have to deal with merge keys and stuff like that, because some of the early decisions we made in Kubernetes, which may or may not be good, around having things like maps with unique entries, or lists with unique entries based on some sort of key, like a name or something like that. So merge keys ends up being an interesting thing that you're gonna have to deal with here, and especially if merge keys are dynamically generated. And then you can do a second one where you actually change things, and then from there you can do an assert. Very cool. And so this looks like a useful thing outside of just KUDO, right? Because like nothing that we had here has anything to do with KUDO. And so that, I think, might be interesting to think about, like, hey, is there a way to sort of break this out as being a way to test things in a Kubernetes cluster? Sorry, Jared, I was just saying that none of this stuff here requires KUDO. It's really an interesting way to think about, applying and testing and breaking it out. Oh, you already did. Okay. So it comes with KUDO, but it also, it looks like it's maybe broken out already. So very cool. Tips and tricks. Loading built images into Kind, Kubernetes event. Oh yeah, because you want to Helm testing, test suite. Very cool. Oh, I like that. That's a really interesting set of ideas there. All right. Well, let me go ahead and so first of all, Jared and the team, thank you so much for joining. Ooh, I got blurry there for a second. Hello. You can tell like my green screen is confused. Am I going to come into focus? Maybe. There we go. Ha. Thank you so much, Jared. And Kuttl is the test tool. Okay, so okay, cool. So this is broken out. Very cool stuff. Definitely let's drop a link to this in the show notes here. Am I spelling Kuttl? There we go. So very cool to see that. Oh, sorry. What I did is I added that to the show notes here. Cool test tool that is not KUDO specific. So my thoughts about KUDO. I think I really, really like that KUDO is a way for folks who don't necessarily consider themselves programmers to start playing in the operator world. And I'm really interested to see where this goes over time, especially with the sort of dynamic CRD creation. The idea that, we can take, the typical operator automates their job by creating a bunch of, bash scripts. And how do we turn those bash scripts and turn the corner from like I have to be at my computer and I have to debug some things before I run my bash script to here's a way to automate this and have it auto remediate and sort of turn those bash scripts into something that is over time you sort of understand the failure modes and you continue to iterate on this stuff. And it's the type of thing that can develop and move forward sort of hand in hand as people build experiences with systems. And I think that's a really, really interesting approach. The fact that the user of this system is not a programmer, but is an operator themselves. And so that is, I think, really, really interesting. And I'd love to, I'm going to definitely keep an eye to see where the KUDO folks take the project. And I think that there's a lot of opportunities to find ways to integrate this and leverage other parts of the ecosystem at large. And I think, doing that in a way such that, the sort of getting started experience that is here right now is not lost, but those who want to become more experts have the ability to get fancier and use more advanced tools. I think that's definitely a challenge with systems like this, but definitely worth chasing down. So very, very cool stuff. Thank you again for Jared and the KUDO team for joining in and helping out. And not sure who's doing TGIK next week, but thank you so much, everybody, for joining me. And I'm going to sign off and we will see you next time. All right. Thank you.